Hello, we're on lesson 85 today. Some more trig equations, no new identities again, but they're coming this week, I'm just going to warn you. So for 85.1, we have 3 tan squared of theta equals 7 secant theta minus 5. And of course it says that theta goes between 0 and 360 to tell us that it's 1 revolution and it's in degrees. We don't have to worry about converting to radians. Alright, so let's see. If you remember, tan squared theta plus 1 is equal to secant squared theta. If we set this equal to 0 the way it is, it's not going to do us any good because we have tans and secants and we can't solve for theta with both of those in there. But we can substitute for tan squared would be secant squared theta minus 1. Pull this over here. So this will be 3 times secant squared theta minus 1 equals 7 secant theta minus 5. And now when we distribute that, everything will be in terms of secant so that we can bring everything onto one side and set it equal to 0. So this will become 3 secant squared theta minus 3. And I'm going to go ahead and subtract the 7 secant theta and add the 5 so that it's already set equal to 0. Now we write it in descending order. So it's 3 secant squared theta minus 7 secant theta. And then minus 3 and plus 5 would be plus 2 equals 0. And I will admit that written in that form, it's somewhat intimidating. So if it'll help you to factor this, because that's what we have to do, I would think of this as 3x squared minus 7x plus 2 and factor that. It is a lot less intimidating looking at it that way. So this would be, have a 3x and an x, and a 2 here and a 1 here, negative, negative. Let's double check that real quick. 3x times x is 3x squared. Outer would be minus 6x minus 1x is minus 7x, and then negative 1 times negative 2 is positive 2. So it's factored correctly. Now, when I set each factor equal to 0, instead of writing x, I'm going to change it back to secant theta. So this will be 3 secant theta minus 1 equals 0, and secant theta minus 2 equals 0. So this is 3 secant theta equals 1, secant theta equals 2, and then here secant theta would be equal to 1/3. All right, so I don't know how you guys feel about it. I'm just going to write those over. Secant theta equals 1/3 and secant theta equals 2. Make sure I did that right, yes. I don't think in terms of secant or cosecant or cotangent. I think in terms of sine, cosine, and tangent. So it's easier for me to think of the reciprocal of this. So the reciprocal of secant is cosine, and the reciprocal of 1/3 is 3. Reciprocal of secant is cosine, and the reciprocal of 2 is 1/2. And now we're going to give the answers where these two statements are true. Now, if you remember from our basic cosine graph from a long time ago, the high point is 1 and the low point is negative 1. So is there any place that cosine is going to be equal to positive 3? No, can't be bigger than 1 or less than negative 1. So there is no solution for that one. Now cosine equal to positive 1/2, we've got a possibility here and here. So this is adjacent over hypotenuse. So 1, 2. Oh, that's a negative 1. So it's, oh, I've got that backwards. Sorry guys, that's sine. Adjacent is 1, hypotenuse is 2. Adjacent is 1, hypotenuse is 2. So what's the angle that's inside of here? Remember, that would be square root of 3. So this is 60, and this is 60. So the two answers that actually work are this one, which is 60. And from here around to here is 300. So there's two solutions for that. We didn't get any solution for this factor over here. Okay, let's try another one. On page 509. So 2 sine squared of x equals 3 plus 3 cosine of x. And this is also in degrees, so we don't have to worry about that part of it. So I've got sine and cosine, which I can't have. So remember that sine squared x plus cosine squared x is equal to 1. So for sine squared, we can substitute in 1 minus cosine squared. So 2 times 1 minus cosine squared of x equals 3 plus 3 cosine of x. And now we'll have everything in terms of cosine. All right, so this gives me 2 minus 2 cosine squared of x equals 3 plus 3 cosine of x. And if I'm going to write this in descending order and make this a positive because it's the lead coefficient, I'm just going to go everything to the right. So 0 equals 2 cosine squared of x plus 3 cosine of x plus 1. And again, just like the last time, if it helps you, write this as 2x squared plus 3x plus 1. It'll be easier to factor that way. So 2x squared plus 3x plus 1 equals 0. We'll factor into a 2x and an x, and it's got to be 1 and 1. These are both positives, so both of these are positives. And now that was in terms of cosine, so when we rewrite this, it'll be 2 cosine of x plus 1 equals 0, and cosine of x plus 1 equals 0. So this is 2 cosine of x is equal to negative 1, and cosine of x is equal to negative 1. Cosine of x is equal to negative 1/2. So these two answers we're going to find solutions for. Cosine is negative in this quadrant and this quadrant. And that's adjacent hypotenuse. So negative 1 and positive 2. Again, there's a square root of 3. So this angle inside is 60. But the answers are actually going to be 60. No, not 60. The answers are going to be 180 minus 60, which is 120, and 180 plus 60, which is 240. So that takes care of these for this one. Now we have to look at this one. Okay, remember our quadrantal angles? It's 1, 0, 0, 1, negative 1, 0, 0, negative 1. And in the parentheses, it's always cosine, comma, sine. So which one of these angles gives us a cosine of negative 1? It's right here, isn't it? So the other angle would be 180. So there's 3 solutions for this one. No point in trying to memorize how many solutions there are going to be because they're all going to be different. All right, let's try another one. And I'm going to have to cut the video off after this next example, and I'll do a separate video and attach it for the hands on the clock problem because I have a meeting to go to in a few minutes. So for 85.3, we have 2 tan squared theta equals secant theta minus 1. And this one is also in degrees, so we don't have to worry about doing anything in radians. We go back to the tan squared x plus 1 is equal to secant squared of x. So for tangent squared, I'm going to substitute in secant squared x minus 1 equals secant theta minus 1. Go ahead and multiply this out. So that'll be 2 secant squared of x minus 2. Because this secant squared is already positive, I know I'm going to move to the left, so I'm going to say minus secant theta. Oops, sorry. This is supposed to be a theta, not an x. And then plus 1 is equal to 0. Which simplifies to 2 secant squared theta minus secant theta minus 1 equals 0. Now, once you've done this a while, you'll get used to it, and you'll probably just be able to factor with the secant in there. But for now, I'm going to write it like this so you guys can see what's going on. Just like I said, it's less intimidating. So this will be 2x, 1x, a 1, and a 1. And this one needs to be negative, so this one's positive. Now, when we rewrite this, I'm not going to write 2x. I'm going to write 2 secant theta plus 1 equals 0, and secant theta minus 1 equals 0. So this is secant theta is equal to 1. And this is 2 secant theta is equal to negative 1. Or secant theta is equal to minus 1/2. And again, I don't feel comfortable working with secants, so instead I'm going to rewrite it with its reciprocal function. So the reciprocal of secant is cosine, and the reciprocal of negative 1/2 is negative 2. Reciprocal of secant is cosine. Reciprocal of 1 is still 1. Okay, back to that graph that I drew for you right here. Cosine can't be above 2 or below negative 2. So this, there's no solution for this. Okay? Just cross it out. No solution from that. And the positive one, okay, we go back to this again. Cosine, sine. Where cosine is positive 1 is right here. So theta is equal to 0, and that's it. There's no other solution for that one. All right. Look for another link in this lesson for the clock problems. I'll do that as soon as I finish my meeting. Thank you.